How about some properties of radicals? Okay, go ahead and read through the simplified radical form. I want to point out just a couple of them. Let's see, the first one. The radicand contains no factor with an exponent greater than or equal to the index of the radical. For this one, if you will always do the prison method, you really don't have to worry so much about this particular form. Okay? You want to make sure that the radicand, or the stuff that's under the radical, does not have a fraction in it. Now you can have a radical in the numerator of a fraction, but you cannot have a fraction under a radical. The denominator of a fraction cannot have a radical. That is probably the most important one right there. That's the one we will use the most. Okay, let's skip down to some properties of radicals. If you have the nth root of two things multiplied together, you can split them up like this. So you could take the nth root of each little part instead of trying to look at the whole thing as a one problem. The same thing is true with a quotient. If you are taking the nth root of two things that are divided, you can split them up. And this one is pretty cool. If you are taking some root of another root, you can just multiply the two indices together. Okay, so let's work a few problems. Maybe it's best if we use the prison method on all of these. So for this one, we have the cube root of this negative. So we know we're going to have, let me go ahead and write my cube root here. We're going to have a -1. 24, if you wrote that in prime factored form, let's see what we would get. 24, that's going to be 4 times 6, 2 times 2, and 2 times 3. So that's 2 times 2 times 2 times 3. Then we have a to the 5th, 1, 2, 3, 4, 5, and b cubed. Alright? Now remember, this tells us how many are going to escape together. So we're going to put them in groups of 3. These 3, these 3, and these 3. But in each one of those, only one survives. So we have a 2, an A, and a B on the outside. Don't forget about this -1. If you have a 1 or a -1, that one's special. It doesn't really need any partners because the cube root of -1 is -1. So we have that -1, and then we have a 2, an A, and a B. But all this other stuff that didn't get to escape, the 3 and the 2 A's, they have to stay in prison. That's it. You have now simplified that radical. Pretty cool, huh? Maybe you should pause this and try the next two and see what you come up with. I'm going to keep working, but go ahead and pause. Okay, so we have 108. That would be 3 times something. 3 times 36. 3 times 6 times 6. 3 times 2 times 3 times 2 times 3. So we have the cube root of 2 2's, 3 3's, and x, and 6 y's. Okay. They won't need to escape in groups of 3 again. We only have 2 2's, so they have to stay. 3 3's, we only have 1 x, so it has to stay. Here's 3 y's. Oh, and here's 3 more y's. So everything that gets to escape will be 1 3 and 2 y's. The 2 2's and the x have to stay in prison. But y times y is just y squared. So 3y squared on the outside and 4x on the inside. So 3y squared cube root of 4x will be your answer. Okay, so how about C? Remember that quotient rule, that we were talking about. We could split this up as the square root of 5 over the square root of 4x squared. Well, the square root of 5, that won't break down because 5 is already prime. But how about the 4x squared? Well, the square root of 4 is 2, and the square root of x squared is just x. So this is completely simplified.